Hello viewers, this is Prof 1 Tutorials. My name is Alfred Amprofi and we are here again to look at mensuration 2. Mensuration 2. In my previous video, we looked at cylinders under mensuration 2. But this particular time, we want to look at the square prism, the square prism, or basically we call it the cube. Now I explained that when you talk about a prism, this is when the top is equal to the base. So the size of the top is equal to the size of its base. They all have equal size and equal dimensions. So now let's get a sketch. So this is a cube or a square prism. So when you check the top, it has a square top and then a square base. Now let's look at some examples of cubes. So we can talk about sugar cube. We have lud die. We have chocomilo. These are all examples of cubes. So when you look at this artifact, this is an example of a cube. So you can see that the top is in the form of a square. It has the same base and each side has the same dimension. So we are going to look at how we can find the volume of a cube and the total surface area of a cube. So now let's start with the volume. In my previous video, I said that anytime you want to find the volume of a prism, for which cube is part of the prisms, and specifically we call it the square prism, just identify the square of the base. So when you look at this artifact, the base is in the form of a square. So area of its base then you multiply by the height. This is the general formula for finding area of any prism. Now because the base is a square, then area of a square is L times L, and this is the height is here. But because it's a square, the height also has its dimension to be L. So over here the height will also be L. And when you multiply L times L times L, we are going to get L cube. So L cube is the volume of a cube because the base is in the form of a square, length times length, its height, which is a three-dimensional figure, so the height is also L. So it's going to be L times L times L, and we have L cube. Now we are moving on to the total surface area of a cube. the total surface area. Now with the total surface area, I'll be using the net to explain. I'll be using the net to explain. So every cube, its net looks like this. So if you want to get the total surface area of a cube, we have 1, 2, 3, 4, 5, 6 squares. So we have 1, 2, 3, 4, 5, 6 squares. And because you are looking for the area, each square has the area to be L squared because it's L times L. That is the area of a square. So this one has L squared, L squared, L squared, L squared, L squared. So now my question is, how many L squareds do we have? We have 1, 2, 3, 4, 5, 6. In that case, the area is going to be 6L squared. And that is the total surface area of a cube. Now, sometimes the question can also ask you to find the total surface area of an open cube. An open cube. Now, the moment its top is open, it means that one of the squares will not be available. So in that case, this is off, and we are going to have the area to be 5L squared. 5L squared. Now, we are going to look at the rectangular prism. The rectangular prism. Rectangular prisms, we also call it the cuboid. The cuboid. So every cuboid has a rectangular base. So this is how it looks like. Alright, so this is a cuboid. Now with the cuboid, we will give some examples of cuboids. So the first example I'll give is a building block. We can also talk about bricks. We can also talk about textbooks. These are all examples of cuboid, and we even have these spices in the form of a cuboid, like Maggi cuboid, Maggi cuboid, Maggi cuboid. They are all examples of a cuboid. Now, let's look at this artifact. This is an example of a cuboid. So you can see that the face here is in the form of a rectangle. The face is the same as what we have here. Then the top is also in the form of a rectangle. So the top is equal to the bottom. Then this side is also equal to this side. So that is an example of a cuboid. Now let's look at the volume of a cuboid quickly. Volume of a cuboid. Now with the volume, generally, is always the area of the base. Because the base is a rectangle, then the area will be L times B, this area of a rectangle, times the height. So here the height, I'll make it H. So it's going to be L times B times H. And this is the volume of a cuboid. Now let's look at the total surface area of a cuboid. The total surface area. So total surface area. Now let me use the artifact to make it very simple. Now from here, the base is the length. So I am using L to represent it. This side is the breadth. That is B. Then this side is the height. So if I am trying to relate to the artifact I have here, this is the length, this is the height, then this side is the breadth. So now I have length, I have height. So with the total surface area, this side is equal to this side. So there are two, this and this, and they are all length, height. Over here we have length and height. So it's going to be 2 multiplying length times the height. That is the first part. Plus, now apart from the face, we have the top. Don't forget that the top also has length. This side is the breadth because this and this, they are equal. So if this side is the breadth, then this side is also the breadth. So we have length times the breadth. And again, the top is equal to the bottom. So there are 2 parts. So it's going to be 2 multiplying length times the breadth. Plus, now the last part will be this side. And here we have breadth and we have height. So if we check this part, we have the breadth, we have the height. And this side is also equal to this side. So there are 2. So we have 2 multiplying the breadth times the height. The breadth times the height. So this is the total surface area of a cuboid. Now, in some questions, they can ask you to find the total surface area of an open rectangular tank, which is similar to an open cuboid, because a rectangular tank, we are talking about a rectangular prism. All right. So when you're asked to find the total surface area of an open rectangular tank. So we are going to look at how its total surface area will be. Now, viewers, an example of an open rectangular tank that we are very familiar with is the paper we have within a matches box. You know, when you have a matches and you pull out the paper you pull from the box where we have the matches sticks in it, that is an example of an open rectangular tank. So you realize that without particular figure, it looks like this. All right, so it looks like this. So with this, then they will pack the matching sticks in it. Now you could see that over here the top is off, is not packed. So if I am still considering this artifact, This side is available, so we have length, we have the height, and here and this part is there, they're available. So we are going to have 2 multiplying the length times the height. Again, this part is available, this part is also available, and here we have the breadth and we have the height. So there are 2, so we have 2 multiplying breadth times the height. But when it comes to the top is off, but the base is available. And with the base, if I want to find the area of this base, is the length times the breadth. So I have plus length times the breadth. So with the total surface area of an open rectangular tank with the length and breadth, you are not going to multiply 2 by 8. Why? Because the top is off, is not available. So this will be the formula for the total surface area of an open rectangular tank. So viewers, we will end here, and in my next video we are going to solve some few examples on cube and cuboid. So stay tuned. Don't forget to subscribe if you haven't subscribed yet. Keep on watching, like, share, and we'll meet another time. Bye bye.